Here are 10 space stories you can listen to in English. Now, let's get started. Cosmic Cartwheel. Imagine a cosmic bullseye created by a galactic collision. Located approximately 500 million light-years from Earth, the Cartwheel Galaxy is a stunning example of a ring galaxy with a diameter of about 150,000 light-years. Its unique structure is the result of a smaller galaxy plunging directly through its center. This cataclysmic event generated a massive shockwave that expanded outward, much like ripples on the surface of a pond. As this wave propagated, it compressed interstellar gas and dust, triggering a colossal burst of star formation along its leading edge, creating the brilliant blue ring we observe today. This event left behind a distinct two-part structure, a bright central core of older yellowish stars, which was the original nucleus, surrounded by the ring of young, hot blue stars. Ring galaxies like this are exceptionally rare in the universe. Consequently, the Cartwheel Galaxy serves as a perfect laboratory for astronomers to study the dramatic effects of high-speed galactic collisions. It provides a representative case for understanding how such interactions can trigger large-scale star formation and fundamentally reshape the architecture of an entire galaxy. Cosmic Antennae. What happens when two galaxies, each containing billions of stars, violently collide? The Antennae galaxies, a pair of interacting spiral galaxies located approximately 45 to 60 million light-years from Earth, provide a dramatic answer. Officially designated as NGC 4038 and NGC 4039, their collision has created long, sweeping tidal tails of stars and gas that resemble an insect's antennae. As the two galaxies merge, vast clouds of gas and dust have been compressed, igniting a powerful starburst, an exceptionally high rate of star formation. This intense activity has spawned thousands of new stars within massive superstar clusters, some of which are hundreds of light-years in diameter. This cosmic collision is not an act of destruction, but one of creation. The entire merger process is expected to take several hundred million years, ultimately resulting in the formation of a single, giant elliptical galaxy. For astronomers, the Antennae galaxies serve as a crucial snapshot of this transformative phase in galactic evolution. Observing this system allows scientists to study the mechanisms of star cluster formation triggered by mergers and provides a real-world example for testing theoretical models of how galaxies evolve. It is a spectacular glimpse into one of the most fundamental processes that shape the structure of the universe. Mice galaxies. What happens when two massive galaxies, each over 100,000 light-years in diameter, collide with each other? Located approximately 300 million light-years from Earth, the Mice galaxies, officially NGC 4676, provide a spectacular answer. This pair of interacting spiral galaxies earned its nickname from the two incredibly long tidal tails of stars and gas that have been stretched out by their gravitational pull, resembling the tails of two mice. These tails extend much farther than the galaxies themselves, serving as a textbook example of how gravitational interaction can dramatically deform galactic structures on an immense scale. This cosmic event offers a crucial snapshot of a merger process that will take hundreds of millions of years to complete. Astronomers use this system to test theoretical models of how galaxies evolve, from their initial collision to their eventual formation into a single massive elliptical galaxy. Interestingly, the tails are not merely trails of cosmic debris. They contain star-forming regions, and scientists are discussing the possibility that new, smaller structures, such as dwarf galaxies, could be secondarily formed from the vast streams of gas within these elongated tails. Cosmic tadpole? Can you imagine a galaxy with a tail stretching for over 250,000 light-years? The Tadpole Galaxy, or UGC 10214, is a disrupted, barred spiral galaxy located about 450 million light-years from Earth, famous for this very feature. Its enormous tidal tail of stars and gas extends for an incredible 280,000 light-years, created by a gravitational encounter with a smaller galaxy. This intruder galaxy passed close by, and its powerful gravity pulled a long stream of material out of the Tadpole Galaxy, forming the spectacular tail that gives the celestial object its name. This immense tail is not just an empty stream. It is dotted with numerous massive clusters of young, bright blue stars. These clusters are active star-forming regions, essentially stellar nurseries born from the displaced gas and dust. Astronomers are particularly interested in these formations because they may represent the birth of new, smaller galaxies, known as tidal dwarf galaxies, which could eventually become independent systems. The Tadpole Galaxy, captured in a famous high-resolution image by the Hubble Space Telescope, provides a clear visual example of how galactic interactions can dramatically redistribute matter and trigger new bursts of star formation. Largest known galaxy? Have you ever considered the sheer scale of the largest galaxy in the known universe? IC1101, located approximately 1 billion light-years away at the center of the Abell 2029 galaxy cluster, is a supergiant CD lenticular galaxy of immense proportions. While our own Milky Way galaxy has a diameter of about 100,000 light-years, estimates suggest IC1101's diameter could be as large as 4 million light-years. This cosmic behemoth is thought to contain trillions of stars, and at its heart lies an ultra-massive black hole, one of the largest ever detected. Such a colossal structure is not born but made through a process of galactic cannibalism. IC1101's tremendous size is believed to be the result of it having merged with and absorbed numerous smaller galaxies over billions of years, drawn in by the powerful gravitational well at the cluster's center. This process of hierarchical merging explains its distinct, vast, and diffuse stellar halo. As such, IC1101 provides astronomers with a perfect case study for understanding how galaxies in dense cosmic environments evolve and grow to such gargantuan scales by consuming their neighbors. Perfect ring galaxy. Have you ever seen a galaxy that looks almost perfectly circular? Hoag's object, located approximately 600 million light-years from Earth, is a ring galaxy that presents astronomers with a stunning cosmic mystery. It consists of a nearly perfect ring of young, hot blue stars surrounding a completely separate, spherical core of older yellowish stars. The outer ring has a diameter spanning tens of thousands of light-years, but what is most peculiar is the vast, seemingly empty gap that separates it from the central core. This unique structure makes it one of the most unusual galaxies ever observed. The origin of Hoag's object remains a major puzzle. Typically, ring galaxies are formed either by a smaller galaxy passing through the center of a larger one, or by the gravitational effects of a central bar-like structure. However, Hoag's object shows no evidence of a recent collision, nor does it possess a central bar. Its high degree of symmetry and isolation make it an exceptional case even among the rare class of ring galaxies. Its formation challenges our understanding of galactic evolution and continues to be a subject of intense debate and study. Nearby Starburst Galaxy. Did you know that some galaxies are experiencing a colossal boom in star creation right on our cosmic doorstep? The Sculptor Galaxy, also known as NGC 253, located a relatively close 11 to 13 million light-years from Earth, is one such celestial object. This intermediate spiral galaxy, with a diameter of about 70,000 light-years, is one of the brightest starburst galaxies in the local universe. Within its central region, the rate of star formation is several times higher than the average rate observed across the disk of our own Milky Way. This intense activity is fueled by immense reservoirs of molecular gas and dust, the raw materials for creating new stars. This furious starbirth is not without its dramatic consequences. The combined energy from countless young, massive stars and subsequent supernova explosions in the core generates a powerful outflow of gas known as a galactic wind. This wind ejects hot gas and heavy elements from the galactic disk into the surrounding halo, a process that can regulate future star formation. Because the Sculptor Galaxy is so close to us, astronomers can study these phenomena with high spatial resolution. This makes it an ideal and standard target for investigating the physics of gas and star formation efficiency within starburst galaxies. Milky Way Twin Galaxy. Have you ever wondered what our own galaxy might look like from the outside? Located approximately 30 million light-years away, the intermediate spiral galaxy NG 6744 is often called the Milky Way's twin because of its striking resemblance to our galactic home. With an estimated diameter of about 200,000 light-years, it features a prominent central bulge and two major spiral arms, closely mirroring the presumed structure of the Milky Way. This remarkable similarity offers astronomers an invaluable opportunity to study a galaxy of our type from an external perspective, something we cannot do with our own. The comparison extends beyond just its overall shape and size. NG 6744's disk is populated with numerous HII regions and young star clusters, indicating a rate of star formation considered to be on a par with the moderate activity within the Milky Way. Furthermore, it is accompanied by several smaller satellite galaxies, which is analogous to our galaxy's relationship with companions like the Magellanic Clouds. This comprehensive resemblance makes NG 6744 a crucial subject for comparative studies, helping scientists better understand the dynamics and evolutionary path of the Milky Way itself. Universe Measuring Galaxy. How can a single galaxy help us measure the scale of the entire universe? For NGC 4414, an unbarred spiral galaxy located approximately 60 million light-years away, its role as a cosmic yardstick is just as important as its appearance. With a diameter of about 56,000 light-years, it is categorized as a flocculent spiral galaxy. This means that instead of having two distinct grand spiral arms, its disk is composed of numerous short, fragmented, and branching arm segments. Using the Hubble Space Telescope, astronomers precisely measured the distance to NGC 4414 by observing Cepheid variable stars, a type of star whose pulsation is directly related to its true brightness. This accurate distance measurement was a critical step in calibrating the cosmic distance ladder, the succession of methods used by astronomers to determine distances to celestial objects. By providing a reliable anchor point at such a great distance, the data from NGC 4414 helped scientists refine calculations for the Hubble constant, the value that describes the expansion rate of the universe. Consequently, this galaxy is significant not only for its unique patchy structure, but also for its fundamental contribution to cosmology and our understanding of the universe's vast scale. 20 billion sun black hole. What is home to one of the largest black holes ever discovered? Located approximately 300 million light-years away in the Coma cluster, the supergiant elliptical galaxy NGC 4889 harbors a true monster at its core. This galaxy is one of the brightest in its cluster, with a diameter extending over several 100,000 light-years. Its most astonishing feature, however, is the central supermassive black hole, which is estimated to possess a mass equivalent to about 20 billion times that of our Sun. This makes it one of the most massive black holes ever detected. The immense scale of both the galaxy and its black hole is thought to be the product of a long history of galactic cannibalism. Scientists believe NGC 4889 grew to its current size by merging with and absorbing countless smaller galaxies over billions of years. Evidence for this process can be seen in its vast, diffuse halo and the thousands of globular clusters orbiting it. This history of mergers not only built up the galaxy, but also continuously fed material to its central black hole, allowing it to achieve its extraordinary mass. Consequently, NGC 4889 is a key object for studying how the largest galaxies evolve in the dense environments of galaxy clusters.